All right, I'm now on page 481, still in Module 10, Lesson 2, so this is going to be part 2 of my recording. They actually have a nice little example done here. However, there is a very important mistake or typo or whatever you want to call it. According to what they graphed, this line right here should have a negative slope, so you need to add the negative sign. Otherwise, it's not going to make any sense. So they do remind you that one of the first things you need to do is just get everything in slope-intercept form, which is what they had to do with the first equation. And now that it's in slope-intercept form, you can see that the y-intercept is 4 and that the slope is 2. So here's the y-intercept of 4. You go up 2 and over 1, or up 4 and over 2, same difference. Okay, and it is a solid line because it says less than or equal to. Okay, the other line is already in slope-intercept form. So we start at a y-intercept of -3, go down 1 and over 2, down 1 and over 2. Okay, and that creates this line. We're going to make that one a dashed line because it just says y is greater than. Now, they've already shaded, but let's just prove to ourselves that they have shaded it properly. Okay, again, whenever possible, I'm going to pick 0, 0 for my test point just because it's easy. If I put a 0 in for y and a 0 in for x, I get 0 is less than or equal to 4. That is true. Okay, so we're talking about this line. So I shade the side that contains that point that's true. So here's the shading for this first inequality. Then I go to this inequality. And again, I'm going to use 0, 0 as my test point. I put in 0, 0. Is 0 greater than -3? Yes, 0 is greater than -3. 0 is not greater than 3, but 0 is greater than -3. So again, I am trying to figure out which way to shade on the dash line. I picked 0, 0. It made that equation true, so I shade that side. So here's the shading for this line as well. So you can see that this extra dark area is where both shaded areas overlap. So this is your solution, okay? Any point in that double shaded area, I guess you could say, would be a solution to this system of inequalities, okay? If you picked a point here, it's a solution to this one inequality, but not both of them. If you picked a solution or a point in here, it's a solution to this solid line, but not the other one. And if you pick a point in here, it is not going to make either one of these inequalities true, okay? And the solution is the area that makes both inequalities true. All right, so B is kind of a try it yourself, so let's do that. What I want you to do is hit pause, see if you can get this graphed. I suggest personally using 2 different colors and then shade with 2 different colors to kind of make it a little easier to see what's what. All right, solve the first inequality for y. You're going to do that by moving the 3x. So y is less than or equal to -3x plus 1. And this second one, all right, the second one, which I'm going to kind of bracket in red, that one's already done for you. So the system is this one that we just had to rearrange, -3x plus 1. And the other one is y is greater than 2/3 x minus 2. You can do your x and y intercept trick, but I'm just going to go ahead. They're both in slope-intercept form, and for me, that's easiest. So I'm going to go down here to, let's see, a +1. All right, +1, and then I go down 3. So 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. And that should give me enough points so that I can draw my line. My line is going to be a solid line because of the less than or equal to part. All right, I think I'm clear of 0, 0, but I'm just going to use 4, 4 for my test point this time. So my y is 4, -3 times 4 plus 1. All right, and it says when I get it all done, is 4 less than or equal to 11? Sorry, is 4 less than or equal to negative 11? No, 4 is greater than or equal to negative 11. So this test point does not make this true. So I'm not shading on the side where the test point was, I'm shading on the other side. So let's do that. All right, I'm going to do the other equation in the other inequality in red. So I'm going to start with the y-intercept, which is at negative 2. And it says the slope is 2/3. So I'm going to go up 2 boxes and over 3, or down 2 boxes and to the left 3. Now, on this one, it needs to be a dashed line because it just says y is greater than. It doesn't say the or equal to. So let me get that drawn. And now let's test it with a point. I can pretty easily see that 0, 0 is nowhere near this line, so I'm just going to use that. So 0 greater than, basically 2/3 times 0 is 0. Is 0 greater than negative 2? Yes. So that test point makes it true, so I need to shade on that side. All right, so I've got my system of linear inequalities graphed. And once again, the shaded, like the double shaded area, that is your solution. Any point in that area will make both of these inequalities true, okay? And the solution has to make both of them true, okay? This area in red makes the red inequality true, but not the blue one. This area in blue makes the blue inequality true, but not the red one. And then, of course, this area that's completely not shaded makes neither one of them true. But the solution is over here, okay? Now, the solution could include points on this solid line in this little part right here, because remember, it's an or equal to, okay? But it wouldn't include points along this line because that's a dashed.